Okay.
Sales comparison model, math appraisal method.
Math appraisal. Math appraisal.
I said math.
Oh, it came out with math.
Math. Are we going to have a problem, Tokabi?
Mm-hmm.
Are you sure? That's going to be your in trouble name. It's Tokabi. Just decided. In math appraisal, depreciation is usually estimated by using depreciation tables, schedules, that illustrate the typical loss in value for structures at various ages or effective ages. By nature, such tables primarily recognize physical deterioration, so additional adjustments are required to recognize functional and external obsolescence. Because different types of structures depreciate at different rates, depreciation schedules should be tailored to each type of structure. Depreciation tables or schedules prepared by cost estimation services must be adjusted to the local market. There are groups of properties that exhibit similar value trends and therefore also show similar trends in physical deterioration, functional obsolescence, and economic obsolescence. Tables based on market data may be developed to provide a schedule of typical standards by which the appraiser can estimate depreciation for these groups of similar properties. The data used to develop these tables usually indicate several things. First, rather than a straight line, depreciation typically follows a curvilinear path. It usually commences quickly at first and then levels off at a point where, with normal maintenance, there is little change for many years, and then accelerates toward the end of the improvement's economic life. Second, depreciation is sensitive to maintenance. Some buildings are better maintained than others and often outlive the economic life normally expected of them. Depreciation tables may be purchased from specialists to develop or developed by the appraiser. In either event, the figures must reflect local market conditions. Usually, the best method for developing the depreciation tables is the sales comparison method. Sales selected for this method should have well-documented land values and not include sales with multiple improvements. If enough sales are available, the percentage depreciation abstracted from the sale properties can be plotted on a graph against effective age, such as percentage depreciation on one axis and effective age on the other axis, or as the other axis. The trends of depreciation can be observed from this graph, and these trends can then be translated into a table showing effective age in one column and percent good in the other. The table can then be used to infer the depreciation of properties similar to those used in developing the table. Developing depreciation tables from comparable sales and mass appraisal is the primary method of estimating depreciation in the assessor's office. The degree of success using this approach requires representative or comparable ages and types because different improvements depreciate at different rates. This requires the stratification of the sales by some common denominator such as quality grade for residential property. The following steps are necessary to develop a depreciation table by using the indirect method of depreciation in mass appraisal with sales comparables. Number 1. Stratify or classify sales by type of structure, such as residential, commercial, and industrial, selecting sales that have a well-documented land value and excluding sales with multiple improvements. Number 2. Subtract land value from sale prices to obtain the indicated value of the improvements. Number 3. Determine the cost new and subtract the improvement value from the cost new to determine the dollar amount of depreciation. Number 4. Divide the results from step 3 by the cost new to obtain the percentage depreciation. Number 5. Plot percentage depreciation against effective age. Number 6. Fit a trend line to the data using a mathematical model to determine the formula for calculating the depreciation. When fitting the curve, it is best to try several fit lines. The 3 most commonly used fit lines are linear, quadratic, and cubic. The linear regression line is a fixed rate of depreciation through the economic life range, commonly referred to as straight-line depreciation. The quadratic regression line tends to start out with a small amount of depreciation and then escalate as the property's effective age increases. The cubic regression line has more of an S pattern in which the depreciation starts out fairly strong but slows down during the middle of the economic life, then accelerates towards the end of the economic life range. The curve fit analysis that produces the highest R, where R is... does it tell us where R is? Oh.
A rate, maybe?
R is...
I wouldn't worry about it. I would just read the text as it is.
Okay. The curve fit analysis that produces the highest R squared is the equation that best fits the data. R squared is a statistical measure of how well a regression line approximates real data points and a descriptive measure between 0 and 1, including how good one term is at predicting another. A coefficient of correlation close to 1 or -1 indicates that the data pairs lie very close to the straight line. Number 7. Construct a depreciation table by using the formula from one of the regression analyses. The formula is the indicated depreciation percentage for each effective age line. Number 8. Construct a percent good table by deducting the depreciation. See Chapter 15, Mass Appraisal, for a more in-depth explanation of curve fit analysis and R squared. The scatter diagram in Figure 10.1 displays the market depreciation for residential properties with a 60-year economic life. 3 different lines have been fitted to the data to help determine which pattern best represents the trend. In this particular figure, the cubic regression line is slightly better than the quadratic regression line. There's no way to describe the mess of Figure 10.1. It looks like I took a toddler and went... That's what it looks like. There are advantages of using the indirect sales comparison method of estimating depreciation in mass appraisal. The calculations for this method are based on sales data extracted from the market. Depreciation based on market data provides better results because it is based on the actions of buyers and sellers in the marketplace. This method is also relatively fast because many of the components are previously determined in the assessment process. For example, both the cost new and the site land value are determined during standard appraisal assessment analysis. There are some disadvantages to using this method. It requires an adequate amount of sales and the development of cost new for comparable properties. Also, it does not provide an accounting of the individual types of depreciation, such as physical deterioration, functional obsolescence, or external obsolescence. For most jurisdictions, data collection, verification, and cleanup are going to be the greatest concern. One example of problems using this technique is that a depreciation curve should start at 0 for new properties and increase over time. When the depreciation curve does not start at 0, the appraiser must recognize that either the cost new is not properly calibrated or the site land value is incorrect. When any one of the curves is applied for depreciation, the curve should be constrained at the tail if it starts to indicate that older properties have less depreciation than the new properties, indicated by a downward slope at the end of the curve. In addition, if a linear equation is being applied, it should be constrained at a point less than 1. If the formula is allowed to extend to 1 or above 1, it indicates that properties completely depreciate or depreciate more than 100%.
Okay.